We'll start again the topic Bode plot. So before going to Bode plot, plotting, let's first discuss the steps that we have to follow while drawing this Bode plot. So first thing we have to do is to put S equal to J omega, right? Because in J omega means because we are varying the frequency omega, so we have to put the value of S equal to J omega in our transfer function. And the next important point is we have to convert our transfer function into time constant form if it is in the pole zero form, right? Because if we convert our pole zero form into time constant form, the gain value will change. So we have to convert it into a time constant form. So then the next step is to identify the corner frequency, right? The corner frequency means the frequency at which two asymptote meets, okay, or two asymptote break. So similarly, then the next step is to we have to draw the asymptotic magnitude plot. Okay, it is not the exact magnitude plot, but it is the asymptotic magnitude plot. Because in this asymptotic magnitude plot, we can roughly estimate the stability of our system. So we don't need to do the actual magnitude plot. So the slope will change at each corner frequency by plus 20 dB per decade for 0 and minus 20 dB per decade for 0. And similarly for complex conjugate pole, complex conjugate poles mean two poles, right? So two poles, so the slope will be minus 40 dB per decade. Similarly for complex conjugate 0, that means there are two 0, so the slope will be plus 40 dB per decade. For complex 0, the slope will be plus 40 dB per decade. So next we have to find the starting point of the magnitude plot on the y-axis. So for different type of system, we have different type of rules. Okay. So if it is a type 0 system, then we have to do this 20 log k, right? For type 0 system, we have to do the 20 log k, and that point will be our starting point, and the initial slope will be 0 dB per decade. So similarly for type 1 system, we have to draw a line having slope this minus 20 dB per decade up to this omega equal to k for type 1 system. Similarly for type 2 system, it will be the slope will be minus 40 dB per decade up to this omega is equal to root over of k. Similarly for type 3 system, omega will be equal to root over of 3 and the slope will be minus 60 dB per decade. And then the next step is to we have to draw a line up to the second corner frequency by adding the slope of next polar 0 to the previous slope. Okay, and then the final step is to calculate the phase angle for different value of omega, and then we have to plot the phase plot. So the phase plot is not that much very difficult, it is very easy. We have to only focus on this magnitude plot, that is our asymptotic magnitude plot. So we discuss this phase margin, gain margin, right? The gain crossover frequency, the frequency at which the magnitude of our system is 1, or we can say the frequency at which the magnitude plot intersects this 0 dB axis. And similarly the phase crossover frequency, the frequency at which the phase angle of our the system is minus 180, or we can say the frequency at which the phase plot intersects the minus 180 degree axis. Similarly phase margin, gain margin, right? The gain margin is the additional gain at the phase crossover frequency that is required to make the system unstable. Similarly phase margin, so it is the additional phase lag. Okay, the phase margin is the additional phase lag at the gain crossover frequency that is required to make our system unstable. So in this side it will be positive gain margin and it will be positive phase margin. So for the system to be stable, both the gain margin and phase margin should be positive, or we can say for the system to be stable, the phase crossover frequency should be greater than the gain crossover frequency. So if the phase margin and gain margin are negative, at that time the system will be unstable. And if the gain crossover frequency and the phase crossover frequency are same, at that time the phase margin and gain margin will be 0. So at that time our system will be marginally stable. So we have already discussed all these things. So let's go to the plotting of Bore plot. So we have discussed this example yesterday. This is a very simple example, right? For this first order, type 1 system. So in this question, we have to draw the Bore plot for the transfer function, and we have to determine the gain crossover frequency, the phase crossover frequency, the gain margin, phase margin, and stability of the system. So as you can see, it is a type 1 system, right? We have the s to the power 1, or we can say there is a single pole at the origin. So it is a type 1 system. So the initial slope will be minus 20 dB per decade. So for type 1 system, we have to mark omega is equal to k, right? Omega is equal to k on the 0 dB axis. The k is 50. So at 50 radian per second, we have to mark that point on the 0 dB axis. And from that 0 dB axis, we have to draw a initial slope of 20 dB per decade. So let's say this is our 0 dB axis. So 20, 40, 60. Okay. So this is our phase angle plot for this line is minus 180. So let's this frequencies. So our frequency is 4 and 10, right? The corner frequency 4 and 10. So I am going to start with frequency 1. 1, 10, and 100. So this is our omega, right? The frequency omega. So it is a type 1 system, right? So the initial slope will be minus 20 dB per decade. And what will be the starting point? To find the starting point, we have to make this omega is equal to k.
Sir, gote pila join karibo ko.
Both pila join ko ken. Acha ta minimize jaychi na, sorry. So we have to mark this 50, right? For type 1 system, we have to mark this omega is equal to k for type 1 system. So k is 50, so 50 will be at this point, right? So 50 frequency, 50 radian per second. So at this point, we have to mark on the 0 dB axis of the magnitude plot. So now from this point, we have to draw a 20 dB per, minus 20 dB per decade slope. So how can we draw? So we have to first measure, right? So this is our 20, 40, this is 60. So I told you yesterday already how to draw this slope. So this is our 1 decade, right? This is my 1. So this is my 1 decade. 1 to 10, that means this is my 1 decade. So from this point, we have to draw this line. Okay, you can draw a straight line. So we have to measure this angle, right? This angle, because this is 1 to 10 is 1 decade, and from this 20 to it is going 0. That means we have a minus 20 dB per decade slope. So this angle will be around 18 or 19 degree. Okay. So this is our 20 this minus 20 dB per decade slope. So but in this Bore plot diagram, we have to draw this minus 20 dB per decade slope from this point, from this omega is equal to k, which is 50. Is 50 radian per second. From this point, we have to draw a line of this minus 20 degree per decade. The same angle, by using protractor, we have to draw a 18 degree. You just measure it. Okay, I forgot that what is the degree. I think it was around 18 degree. Okay. So for that much degree, with this reference line, we have to draw up to this y-axis. So the line will be like this one, right? So this is our minus 20 degree per decade slope. There are minus 20 per decade slope. So the next step is we have to identify the corner frequencies. The corner frequencies are, we have only two poles. So this is the T1 is 0.25 and the T2 is 0.1. So omega 1 is 1 by T1, so it is 4 radian per second. The second corner frequency is 10 radian per second. So, so 4 will be around this point, right? This will be 4. So at this point, we will have this 4 radian per second. So that means up to this point, we have to mark on this asymptote. Okay. At 4 radian per second, we have to mark at this point. So you can erase this, or if you want, you can use the dotted line. Okay. So next we have to see this 4, this corner frequency 4 is from a pole. So that means a single pole means earlier the slope was, it was minus 20, and now there is another pole. So we have to add another minus 20. So now this slope is minus 40 dB per decade. The next slope that will be starting from the corner frequency 4 will be minus 40 dB per decade. So from this point we have to draw minus 40 dB per decade. So how do we draw the minus 40 dB per decade? So similarly, we have to measure the angle for this 40 dB also. Okay, this angle will be for this 40 dB per minus 40 dB per decade. So with this reference line, we have to draw that angle by using the protractor. So it will be like this one. Okay, so this line is now this minus 40 dB per decade. So it will go up to the next corner frequency. So the next corner frequency is 10. And this one is 10. Up to this point. Up to this point is our next corner frequency 10. So the next corner frequency, it belongs to a pole, right? It belongs to a pole here. You can see 1 plus 0.1s. So it belongs to a pole. So we have to add another minus 20 to our slope. So now the final slope is now minus 60 dB per decade. Similarly, for this 60, you can measure the angle, right, by doing a dotted line up to this decade and this angle. This will be around 45 or something. So similarly, from this, with reference to this line, we can draw a 45 degree axis. So this will be our this minus 60 dB per decade slope. Clear na? Kar doubt achi magnitude plot re slope guda kemti draw karibo? Clear? Kemti angle ta measure kariki?
No, sir.
Okay, very good. So next is the phase plot. Okay, so you can see here it is a pole at the origin. So if you write the angle, then it will be by putting s equal to j omega, we will get the angle will be, because it is at the pole, we will get minus tan inverse of omega by 0, right? Because s equal to j omega, so imaginary part by real part. Similarly, minus tan inverse of what is next is 0.25. Yes, we have written s equal to j omega, so 0.25 omega divided by the real part 1. So it will be tan inverse of 0.25 omega. Then we have another pole, so it will be tan inverse 0.1 omega. This will be our final angle. So this angle will be 90 degree, right? This angle will be 90 degree. So you don't have to write this tan inverse of omega by 0. You can directly write minus 90. If there is a single pole at the origin, it will be minus 90, and double pole at origin, it will be minus 180, and there is a triple pole at origin, it will be minus 270. So we don't have to write that tan inverse of omega by 0. Okay, you can directly write the angle here. So the next step is we have to vary this value of omega until this phase angle value crosses 180. तो टेबल यूज करिया शिखिल समस्ते कैलकुलेटर रे किंतु टेबल यूज हबो ना ट्राई करी न शिखवाला इग्नोर हरियाणा एग्जाम टाइम रे. So we can see here for this j omega, that is s, right? S equal to j omega. These are all 90. Similarly, for the next angle is minus tan inverse of 0.1 omega. So different value of omega 1 to 100 is taken. Different value of this minus tan inverse of 0.1 omega. Similarly, minus tan inverse 0.25 omega. The resultant will be the summation of these three angles. So you can see it has already crossed the minus 180 degree axis. The next step is we have to plot this phase plot. Okay, so 109, so we have to draw some line at frequency 1. It was 109. Similarly, it will go like this one. At how much frequency you are shooting? Before 10 it is intersecting 180 degree line, so it will be like this one. The dots will be like this one. So then we have to connect the dots. Okay, so next we have to determine the phase crossover frequency and gain crossover frequency. So you know the gain crossover frequency is the frequency at which this magnitude plot intersects this 0 dB axis. So you can see at this frequency it is intersecting the 0 dB axis, right? At this frequency, so we have to find the frequency in this axis. It will be around 8 or 9 radian per second. यदि मो डायग्राम ठीक कर ठीक बाहरिबो तो गेन टा अछि हमरा 13 रेडियन पर सेकंड. ओके, 13 रेडियन पर सेकंड. तो मो डायग्राम टिके भूल अछि. सो ग्राफ पेपर में करिया ठीक एंगल मेजर करी कि ताहेले ठीक आसीयो. तो यदि हम एई डायग्राम कंसीडर करिबा देन आई एम गेटिंग माय गेन क्रॉसओवर फ्रीक्वेंसी एट अराउंड 8 रेडियन पर सेकंड. सिमिलरली दिस फेज क्रॉसओवर फ्रीक्वेंसी केते आछि? अराउंड दिस 6 radian per second, right? Phase crossover frequency टा कोन? The frequency at which the phase plot intersects the minus 180 degree axis. So it is around this 6 radian per second, and it is around 8 radian per second. But in the exact diagram, the gain crossover frequency is 13 radian per second, and the phase crossover frequency is 6.5 radian per second. So you can see is less than the gain crossover frequency, so our system will be unstable. Similarly, the phase gain margin can be calculated from this plot. So the gain margin is calculated at the phase crossover frequency. From the phase crossover frequency, we have to draw a straight line until it intersects the magnitude plot, and we have to see what is the distance between this intersection and the 0 dB axis. So in this case we can see it is minus 13, right? It is minus 13. Similarly, from this side the phase margin, it will be calculated from this gain crossover frequency. So the gain crossover frequency, you have to draw a line up to the phase plot. So you can see it is minus 36 degree. So from the graph we have to determine what is the value of this distance from this minus 180 to this intersection point. So you can see here we are getting both the gain margin and phase margin negative. So the system will be unstable. Clear? एथिरे बड़े प्लॉट रे ना किछि डाउट अछि? So can anyone tell me then what will be the final slope for this transfer function? The final slope of the asymptote for this transfer function?
minus 20 dB per decade.
minus 20. Ito ko minus 20 na 40.
So minus 40 dB per second per decade.
Oh, yes, minus 40 dB per decade, right? Because আমার দুইটা জিরো আছে চারটা পোল আছে, সো দুইটা জিরোর কোন হবো দুইটা প্লস 20 dB per decade আসিব আর চারটা পোলর মাইনাস 40 dB per decade, সরি মাইনাস 20 dB per decade আসিব। তো 4 এটার মাইনাস 20 হলে মাইনাস 80, এটা হলা প্লস 20 র দুইটা প্লস 40, সো the final slope will be minus 40 dB per decade. So first हम decide करिया corner frequency. The first corner frequency from this pole, right? From this pole is this 0.33. The 0.33 is our first corner frequency, and the second corner frequency will be देखिए value है corner frequency रो. Then the second one is for this 0, the corner frequency is 1, and then similarly for this pole the corner frequency is 2, and similarly for this 0 the corner frequency is 5, and for this pole the corner frequency is 10. Right, so we have the corner frequency 0.33, 1, 2, 5 and 10. Okay, so then we have to plot it. So we can see it is a type 1 system. So the initial slope will be minus 20 dB per decade, and the value of gain is 23.7. So at 23.7 in the 0 dB axis we have to mark a point, right? At this point, this is our 23.7 radian per second. So from this point we have to draw a minus 20 dB per decade slope up to the y axis. So this is drawn of this minus 20 dB per decade. So our next corner frequency is, or the first corner frequency is 0.33. Okay, the first corner frequency is 0.33. So this 0.33 it belongs to a polar 0 we have to see. So you can see it belongs to a pole, right? This 1 plus j 3 omega. So that means we have to add a slope of minus 20 dB per decade. So for this corner frequency the slope will be minus 40 dB per decade, because we have already a initial slope of minus 20 dB per decade for this j omega. So we have to draw minus 40 dB per decade slope from the frequency is 0.33. So this will be, the next step will be like this one. Similarly we have to see what is the next corner frequency. After 0.33 the next corner frequency is 1, right? So 1 means the corner frequency is 1, and this 1 comes from a 0, right? From this 1 plus j omega, it is the corner frequency of this 1 plus j omega. So this 1 plus j omega is a 0. So that means we have to add plus 20 dB per decade to this minus 40 dB per decade slope. So that means the slope will be minus 20 dB per decade from this corner frequency 1. So from this corner frequency 1, right, this is our corner frequency 1 at this point. We have to draw a minus 20 dB per decade slope. So we have minus 20 dB per decade slope up to the next corner frequency. So the next corner frequency is 5, and the 5 is from a pole, right? This corner frequency 5, 5 thila 2 thila 2, sorry 2. This 2, okay, 1 plus j 0.5 omega. So the corner frequency is 2. So from this frequency 1 to 2 we have to add a slope of again minus 20 dB per decade, because this corner frequency 2 belongs to a pole. So we have to add another corner frequency 1 to 2. Okay, ठीक है. भूल लग दी बोधे so from this corner frequency the initial slope our previous slope टा कितने थिला minus 20 per decade, so we have to add another minus 20 per decade, so it will be the next slope will be minus 40 dB per decade. So it will go up to the next corner frequency 5. In the 5, the corner frequency 5, it belongs to a 0, so we have to add plus 20 dB to this minus 40 dB, so we will get the slope of minus 20 dB per decade. So from the corner frequency we have to draw this minus 20 dB per decade slope up to the next corner frequency. The next corner frequency is 10, and this 10 belongs to a pole, so we have to add a minus 20 dB per decade to this previous slope of this minus 20 dB per decade. So our final slope will be minus 40 dB per decade. So from the corner frequency 10, or that is our last corner frequency, so from that point we have to draw a minus 40 dB per decade slope. So it should go to the next corner frequency. As we don't have the next corner frequency, so we just have to leave it like this. Okay, you don't have to intersect this magnitude plot to this phase plot. So similarly same we can determine this angle. So angle will be for this j omega, it will be minus 90, right? Minus 90, then minus tan inverse of 3 omega minus tan inverse of 0.5 omega minus tan inverse of 0.1 omega, then plus tan inverse of omega plus tan inverse of 0.2 omega. पोल जोड़ा अच्छे सब माइनस हम और जीरो वाला जो न्यूमरेटर अच्छी सब प्लस हम, राइट? So then we have to vary the value of omega from 0 to जो जाए हमारा minus 180 क्रॉस करियो देखिया जाए 20 जाए नीचे एक केस रे 163 जाए आसी, तो 25 की 30 लेके चेक करि परिबो केते आसुची, बट एई केस रे हमर कोन हबो एटा 180 को क्रॉस करिवो नेला, सेमती ही चलियो, सेमती पैरेलली चलियो 180 पाखा पाखी की 175 178 ही चलियो, सो 180 को क्रॉस करिवोनी। तो जो वैल्यू रे पाखा पाखी समान वैल्यू पळे आसीबो सेई जगह रे तुमको आउ आकु जीवन नै हला, माने कर 178 कांस्टेंट आसी तापर जते फ्रीक्वेंसी चेंज करले भी, तो तापर तुमको आकु जीवन नै, तो छाड़ दो सेटा सेटा हबो हमरो इनफाइनाइट जे छाड़िया को पड़ियो। तो एई केस रे हम कोन देखिया, एई केस रे हमरो गेन क्रॉसओवर फ्रीक्वेंसी अछि बट phase crossover frequency nahi, right? Because this phase plot is not intersecting the minus 180 degree axis, so it may intersect at the infinite, so the phase crossover frequency will be infinite, and similarly the gain crossover frequency will be this one, this value, it will be around this 6 or 4 or 5 is not written, okay. It will be around this 5 radian per second, this gain margin 2, 3, 4 will be 4 radian per second. The gain crossover frequency will be 4 radian per second, and the phase crossover frequency will be infinite. So you can calculate this phase margin, it is plus 34 degree. Similarly, the gain margin should be calculated at the phase crossover frequency. So as we are getting our phase crossover frequency is infinite, so our gain margin will become infinite, right? It may intersect at infinite, so the gain margin will be infinite. So we can say our system is stable, right? Because the phase crossover frequency is greater than the gain crossover frequency. So this one is a tricky one, okay, so just bear with me, okay. So we can see here in this g of s, it is given s plus 3 s into s square plus 16s plus 256, right? So you can clearly see that this transfer function is given in pole zero form. It is given in the pole zero form, right? S plus 3. So we have to convert it into the time constant form. So to convert this into time constant form, we have to take the 3 common here from the numerator, and from the denominator we have to take 256 common, right? So we can solve like this, and we will get in time constant form 6 into 1 plus s by 3 divided by s into s square by 256 plus 16 by 256 s plus 1. Clear? we have to convert it into the time constant part. So what will be the final slope? Can anyone tell me what will be the final slope for this transfer function?
Sir, minus 20.
Minus 20. দুই তিনই না
Minus 40.
minus 40 তিনটা পোল ଅଛି ନା
Yes, sir.
তিনটা পোল ଗୋଟେ ଜିରୋ ସୋ minus 40 per ticket ହବ ଆମର ଫାଇନାଲ ସ୍ଲୋପ। ସୋ ଏଇ କେସରେ କମ୍ପ୍ଲେକ୍ସ କଞ୍ଜୁଗେଟ୍ କେସରେ ଆମେ କର୍ନର ଫ୍ରିକ୍ୱେନ୍ସି କେମିତି ବାହାର କରିପାରିବା? ଏଠି ତ ଆମର କର୍ନର ଫ୍ରିକ୍ୱେନ୍ସି ବାହାରି ଯିବ s equal to 3 ବଟ୍ ଏ କମ୍ପ୍ଲେକ୍ସ କେସରେ ଆମେ କର୍ନର ଫ୍ରିକ୍ୱେନ୍ସି କେମିତି ବାହାର କରିବା ହେଲା? ତ ତା ପାଇଁ ଆମର ଅଛି ଏଇଟା we know this one the standard second order system s square plus 2 zeta omega ns plus omega n square, right? The standard form s square plus 2 zeta omega ns plus omega n square. So omega n is 16. Then calculate that the omega n is 16. So this will be our corner frequency. This omega n will be our corner frequency. The on-damped natural frequency will be the corner frequency. Then how can you calculate the angle for this complex conjugate? This second.
Sir, minus 40 কিন্তু ওটি আউটসাইড স্যার পাইবেন।
তিনটা পোল ଅଛି না?
Yes sir.
তিনটা পোল ପାଇଁ କେତେ ହେବ? minus 60 degree per decade. ଆଉ ଗୋଟେ 0 ଅଛି ତ plus 20 degree per decade. ତ final ଟା minus 40 ହେବ। ତ ଏହାର corner frequency କେତେ ହେବ? ଯଦି s square term ଥିବ the corner frequency will be equal to omega n, right? Because it is a standard second order this system. We can say the standard second order denominator. So the omega n will be the corner frequency. So this is our s square plus 2 zeta omega ns plus omega n square. So omega n is 16 radian per second. So similarly, we have to calculate the zeta also in this case. The zeta is 2 zeta omega n is 16, right? Or you can compare like this one also with this also. We don't have to compare this one. You can directly find this value. Omega n will be root over of 256, which will be 16. And similarly, the 2 zeta omega n is 16. If omega n is 16, so we will get the value of zeta to be 0.5. So omega n and zeta. So now this omega n is our corner frequency with this pole or this complex conjugate pole. So now the angle, what will be the angle? So for this angle, okay, we can write this angle. If we put s equal to j omega here, right? So it will be this equation. If we put s equal to j omega, here, this one will become minus omega square plus this s is j omega, so j 2 zeta omega n into omega and plus omega n square, right? So we know the angle is I is tan inverse of imaginary part by the real part, right? Imaginary by the real part. So in this equation, the imaginary part is 2 zeta omega n into omega, and the real part is omega n square minus omega square. So we can write this angle phi is equal to tan inverse of 2 zeta omega into omega n divided by omega n square minus omega square. Right? We don't have to remember this one. If you understood this equation, then you can easily formulate this formula for this angle calculation of a second order system. So if it is in the denominator side, it will be minus, and it is in the numerator side, it will be plus, right? The clear phase angle calculation of a complex this complex conjugate pair of pole. So now we have two corner frequency, right? One is 3 and another is 16. The two corner frequency 3 and 16. 0 dB, this is minus 180. So we can see this is a type 1 system, right? So for type 1 system, we have to mark this omega is equal to k. So what is the value of k for this transfer function? Anyone? What is the value of k?
Sir, 6.
6, right? So बड़े confuse होने वाला सब बड़े time constant form में जोड़ा ऐसी हो सेटा को तुम्हें नबो k value बोल जीरो जब नहीं करियो 512 कर दो ताले भूल लीजिए. So this is a type 1 system, so we have to mark this omega is equal to k, that is 6 on the 0 dB axis. So let's say this is 1 and this is 10. Okay, 1 decade, so 6 will be around this point. Okay, this is our 6. So from this point, what will be the slope? We have to draw. तो स्लोप कितना हुआ ये पॉइंट रू
-20 decimal.
-20 dB per decade, right? So ये पॉइंट हम ड्रॉ कर रहे हैं -20 dB per decade up to this y axis. So this will be now our starting point. Here -20. So this corner, this asymptote should go up to the next corner frequency. So here the next corner frequency is 3, and this 3 comes from this 0. So that means we have to add plus 20 per decade to this initial slope of -20 per decade. So we have earlier -20, and then we have to add plus 20 because the corner frequency 3 belongs to a 0. So up to this point, right, it will be -20 per decade, and from this 3 radian per second, we have to add or we have to draw a 0 dB per decade slope, right? So it will be a 0 dB per decade slope up to the next corner frequency, that is 16. So 16 will be around here. So let's say this is 16, okay. Because the next corner frequency is 16. So up to this point, we have to draw a 0 dB slope of the next corner frequency 16 equal 0. Because the next corner frequency omega n is equal to 16, right? So 16 jaya mein over this 0 dB per decade slope. So now from the 16 radian per second, we have to draw another slope. So what will be that slope? From the 16
-40 dB per decade.
minus
-40 dB per decade.
yes -40 dB per decade, right? Because this 16 belongs to a complex conjugate pole. That means we have 2 poles. So for 2 poles, it will be a -40 dB per decade. Up to the next corner frequency, if available. As we don't have the next corner frequency, we can only leave like this. Okay. This is our 0, and this is -40. Clear? I think everyone is clear about this magnitude plot. यदि कार डाउट अच्छी magnitude plot ऊपर को हो हमको एवरा लिखिया दरकार नहीं, हम कल तुम जानिया पे लिखी जे ए पॉइंट बोली तो ऑलरेडी गोटे y एक्सिस हबो से y एक्सिस तुमको दो फ्रीक्वेंसी लिखिया अछि. अब कार डाउट अच्छी magnitude plot रे ताले फेज प्लॉट करी हबो आराम रे इजी रे किछि नै. सो एंगल टा केते हमरा फेज एंगल टा फाइ इज इक्वल टू we can write so you can see we have a pole at the origin, right? We have a pole at the origin, so it will be -90 first, or we can write -10 inverse of omega by 0 as you wish, but it will be -90, so better you can directly write -90. Similarly, plus, because we have a 0 here, plus the real part is 3, this imaginary part is j omega, right? If you put s equal to j omega, it will be j omega plus 3. So the real part is 3 and the imaginary part is omega. So we can write plus tan inverse of omega by 3. और तुम डायरेक्टली लिखि पारिबो एटी है ना s by 3 अछि, it will be j omega by 3 divided by 1. So same omega by 3. So then minus, because then we have pole, right? This pole minus what will be this angle? It will be tan inverse of 2 zeta omega into omega n divided by this omega n square minus omega square. This will be the angle for this second order equation. Okay. So clear equation लिखे रे कार इस प्रॉब्लम अछि फेज एंगल इक्वेशन लिखे रे कार एटा बहुत इजी अछि समस्त टिके ट्राई करले हे जिवो हला. The next step is to we have to vary this omega from 1 because you have taken one frequency here, so let's start from 1. So को जाय नबा में जो जाय हम उठे either it will intersecting the 180 degree axis और नहले उठे constant line आछला. Suppose एई केस रे हमर केते आछि constant value आछिबो लास्ट 163 172 हला तापर से प्राय constant value ही आसीबो तेति पे से आ आकु नै हला से 170 180 तळो ही आसीबो. सो intersect करिवोनी. So we can write this phase crossover frequency is infinite. हला तो ट्राई कर देखियो केते रे आछि ए केसे infinite लिखिछि बोधे लिखिनि किछि अछि. तो सिमिलरली गेन क्रॉसओवर फ्रीक्वेंसी, फेज क्रॉसओवर फ्रीक्वेंसी, फेज मार्जिन, गेन मार्जिन बाहर करि परिबा. तो एई केस रे गेन मार्जिन केते हबो के कहि परिबो ए डायग्राम रो गेन मार्जिन केते हबो सर गेन मार्जिन को भूलो को किछ सुविधा नहीं
सर इनफिनाइट.
यस इनफिनाइट हबो लगा कि हमर फेज क्रॉसओवर फ्रीक्वेंसी इनफिनाइट अछि. तो इनफिनाइट रे हमर गेन मार्जिन आसीबो. सिमिलरली हम फेज मार्जिन दल बाहर करिया ताले हमें ए पॉइंट टू लाइन ड्रा करिबा अप टू दिस पॉइंट. तो ए पॉइंट टू ए पॉइंट हम कैलकुलेट करिया अछि. तो -180 ए पॉइंट आछि अबाउट केते 120 राइट. -120 टू -180. सो तो फेज मार्जिन केते हबो अराउंड 60 डिग्री. फेज मार्जिन हबो पीएम टा हबो 60 डिग्री. तो सिस्टम रा स्टेबल ना अनस्टेबल
अनस्टेबल
अनस्टेबल काहे के अनस्टेबल हला कोन भाभी कहिलो अनस्टेबल हबो स्टेबल हबो ना काहे ना हमरा फेज क्रॉसओवर फ्रीक्वेंसी is greater than the gain crossover frequency. Can a phase crossover frequency infinite अछि और gain crossover frequency टा around केते अछि 40 आड अछि. So phase crossover frequency is greater than the gain crossover frequency. At that time we will get a stable system. सेमती फेज मार्जिन हमरा पॉजिटिव अछि ना एटा -100 this -180 +60 डिग्री अछि हमरा फेज मार्जिन टा. So ए टाइम रे सिस्टम स्टेबल हबो. तो ताहले तुम जाए स्टेबल अनस्टेबल क्लियर ना क्लियर नुह को आगरो बड़े प्लॉट हम केमते चेक करिया. खाली देखियो यदि फेज क्रॉसओवर फ्रीक्वेंसी टा ग्रेटर देन अछि गेन क्रॉसओवर फ्रीक्वेंसी रो सेही टाइम रे हम सिस्टम स्टेबल हबो. क्लियर एटी हमर इनफाइनाइट अछि फेज क्रॉस फ्रीक्वेंसी और गेन क्रॉसओवर फ्रीक्वेंसी अछि 20 रेडियन पर सेकंड. तो सिस्टम विल बी स्टेबल. This is also important one.
Phase margin और gain margin positive है.
आउथर कहबी
फेज मार्जिन और गेन मार्जिन पॉजिटिव थिले तो स्टेबल हो ना.
हां तो तुम फेज मार्जिन के न बाहर करबी न बाहर करके भी कहि परिबो हला जो क्रॉसओवर फ्रीक्वेंसी देखि जदि तुमको बाहर करिया पई कहि दियो जे फेज मार्जिन गेन मार्जिन ताले बाहर करिवो और नहले यदि खाली लिखा थिबो जे कमेंट ऑन द स्टेबिलिटी ऑफ द सिस्टम बाय यूजिंग द बोर्ड प्लॉट ताले तुम प्लॉट ड्रा करके जानि परियो को फ्रीक्वेंसी टा अधिका अछि से हिसाब रे तुम कहि परियो जे सिस्टम स्टेबल ना अनस्टेबल.
Okay, sir.
So this is an interesting one. If transfer function ଆମେ Bode plot draw କରୁଥିଲେ, so how can we determine the transfer function from the magnitude plot? Okay, so you can see here, this is our magnitude plot. So can anyone can guess what will be the this type of the system?
So type 0.
Yes, type 0 होगा ना, start initial कौन सी slope टा 0 dB per decade, right? So type 0 system आसियो. So then pole आसियो -20 per decade, then -60, then -180 अछि. The first corner frequency is 5, right? So 5 ru start ହେଇଛି -20 per decade. So that means it will be 1 plus s by 5. The first term टा हबो 1 plus s by 5. And similarly, it is going up to the next corner frequency 40. A corner frequency 40 रे हमरा चेंज ହେଇଛି 60 dB per decade, right? 8 point रे 20 रो डायरेक्ट हला -60. ता माने हमर कोन डबल पोल अछि, राइट? यदि हम -20 रो -60 हला माने डबल पोल अछि. ता corner frequency केते 40. So 1 plus s divided by this 40 into whole square, because we have this let's say this double pole. Okay, this is double pole. Similarly, then another -20 is added. That means there is another pole at this 100 radian per second. Then it will be 1 plus s by 100. And then we will determine the value of k. The value of k will be this 20 log of k is 100, right? Because for type 0 system, we are determining the initial point by using the 20 log of k. So 20 log k is 100, so k is 10 to the power 5. So we can write the transfer function as 10 to the power 5 divided by 1 plus 0.2s into 1 plus 0.025s whole square into 1 plus 0.01s. So this will be our transfer function from the Bode plot. Similarly, next question is estimate the phase at each of the corner frequency. It is a frequency हमारा phase angle plot में केमती करी परिबा. So for different this frequency, this will be a phase angle. So हमें roughly plot करी परिबा phase plot टा भी यही तीन टा frequency रे. सब माइनस हम, राइट? सो पोल जो डिनोमिनेटर अच्छी सब एंगल माइनस हम, ऑलरेडी कॉमन नहीं जाइए. सो प्लस tan इनवर्स ऑफ 0.2, राइट? दिस इज 0.2 into omega, and omega is taken as 5. So 0.2 into 5, then this 2 a double pole, so 2 into tan inverse of 0.025 into omega is equal to 5. So 0.025 into 5. Similarly, for this one, third one, tan inverse of 0.1 into omega is taken as 5. So this angle we are getting is minus 62.11 degree. That means at the frequency of 5 radian per second, the phase angle of the phase plot is minus 62.11 degree. Similarly, at 40 degree, we can calculate by replacing omega is equal to 40, and similarly at 100 radian per second, we can calculate the phase. So this can be converted into this pole 0 format. Okay, कोड स्कैन कर देली छाड़ दी गोटे पेज बोधे एटा नुह. दिस इज नॉट द कंटिन्यूएशन ऑफ द प्रीवियस पेज. तो कहार किसी डाउट अच्छी बोर्ड प्लॉट ऊपर यदि कहार किसी डाउट नहीं ताले मैं क्वेश्चन पचारि. सिंपल क्वेश्चन पचारि देखिए जब जो बुझी थी से कहि पारिबो. So till now we are taking, right, the pole at the origin. If 0 at the origin थी ताले कौन हबो के कहि पारिबो. Suppose you have transfer function of this tan into s okay, into s plus 2 divided by s plus 3 s plus 4 into s plus 5. এই কেস আমি স্টার্টিং পয়েন্ট কেমতি বাহার করিয়া কুহ
प्लस 20 dB per decade start हो
हाँ हाँ कुह किसी डरिया नहीं कुह
तो प्लस 20 dB per decade start हो
प्लस 20 पर डेकेड स्लोप हाँ स्टार्टिंग स्लोप हम जे को पॉइंट ड्रॉ करिया स्टार्टिंग पॉइंट जो हमर अछि मैग्नीट्यूड रे ए पॉइंट हम केमती बाहर करिया एटा तळु एटा 0 dB हेले एटा पॉजिटिव एटा नेगेटिव अछि तो एटा एपोटो भी स्टार्ट हे पारे नल एमटी भी स्टार्ट हे पारे तो केमती जानिया को पटे जीवो
पॉजिटिव स्लोप
पॉजिटिव जीवो सी नेगेटिव रो कहीं जाई परियोनी नेगेटिव रो जाई परियो तो फर्स्ट स्टेप है हमको या कौन करिया हमें या को हम करिवा टाइम कांस्टेंट फॉर्म को हला फर्स्ट हमें टाइम कांस्टेंट फॉर्म को आनिवा तो मैं ड्रॉ न कर तो मेटलेब रे देखै दउची सीधा टाइम कांस्टेंट फॉर्म को आनी केमती होबो 2 मिनिट लागियो जस्ट वेट फॉर 2 मिनिट तमे चाहिले हाथ ड्रॉ करि पारिबो तुमका देख बुझै दउची खाली एडी हमरो 0 रे अछि ओटे एलो अछि -2 -2 -3 -4 -5 this is our transfer function 10 into s into s plus 2 divided by s plus 3 s plus 4 s plus 5 so एटा अछि हमर कोन पोल 0 फॉर्म रे सब ताको हमें करिया टाइम कांस्टेंट फॉर्म को now this has become our time constant form right agar thila s into s plus 2 but ebe s into 1 plus 0.5s now this 0.5 is the time constant similarly denominator re bhi se ai gala time constant form ko asi gala so now ebe amar gain ro value kete 0.0333 sorry 0.333 right तो एकदम ड्रॉ करिया बोर्ड प्लॉट स्टार्टिंग इनिशियल स्लोप टा हो पोस्ट प्लस 20 पर डेकेड देखो माइनस स्टार्ट लगा प्लस तो स्टार्ट हलानी प्लस रु तो माइनस को जाई छी ओके सो अराउंड 6 राइट फ्रीक्वेंसी हमरो ए केस रे 6 आछि जोटा हमर मैग्नीट्यूड 0 dB रहउछि राइट मोटा करिया ये लोग बड़े पड़ेगा विकास या कथा मोर प्रॉपर्टीज रे लिमिट स्टाइल କୋଉଠି ବାହାରି ଯାଉଛି ଜଣା ପଡୁନି। ଦରକାର ନାହିଁ। ओके ठीक ଅଛି ପରେ ଦେଖିବା ସେଇଟା। ସୋ ଏଇ କେସ୍ ଆମର 0 dB ଏକ୍ସିସ୍କୁ କେତେବେଳେ କଟ୍ କରୁଛି ଯେତେବେଳେ ଆମର ଫ୍ରିକ୍ୱେନ୍ସି ଅଛି around this 6 ରାଇଟ୍ 6 ରେଡ଼ିଆନ୍ ପର୍ ସେକେଣ୍ଡରେ ଆମର କଟ୍ କରୁଛି। ବଟ୍ ଏଇ କେସ୍ରେ ଆମର କେତେ ଅଛି ଗେନ୍ ଭ୍ୟାଲୁ କେତେ ଅଛି 0.33। मैं भूल कर देली कि बोर्ड ऑफ G1 तो ठीक अच्छे। सी रे इंटरसेक्ट करिया कथा कैमरा देखिया पड़ो एटा कैमरा कौन भूल कर देछि एठी। तो एटा हमर कोन हो कहलो जो न्यूमरेटर s अछि तो यदि हम ताको डिनोमिनेटर आनी तले कोन हो 1/s इट विल बी 1/s याको तळ को आनीबा देन इट विल बी 1/s will be 1/s। तो पोलेट ओरिजिन में कौन करथिले ओमेगा इक्वल टू k वैल्यू रे हमें ड्रॉ करथिले -20 पर डेकेड राइट। बट एई केस रे हमें 1/s तो ऐड करूचे सो दिस ओमेगा वैल्यू विल बी दिस 1/k राइट 1/k। तो ए 1/k वैल्यू रो हमको ड्रॉ करियर अछि +20 पर डेकेड ओके +20 पर डेकेड ड्रॉ करिया। इन केस ए टाइम रो k रो वैल्यू कोन 0.33 अछि एटा 6 ऑफ 6 कोन बडे मत देखिया पड़ो ठीक है। लेकिन नेक्स्ट क्लास रे कहिबे एटा 3 रे आसिया कथा मैग्नीट्यूड 0 होबा कथा। सो यही केस हम देखि पारि हमर मैग्नीट्यूडटा 0 होची एबार 0.669 रे हला। सही केस रे हमको बाहर करिया पड़िबो एठू केते आसीबो 1/15 वाला केते आछी
0.06
तो यदि हमरा पोल 0 ओरिजिन अछि देन हमको 1/ओमेगा इक्वल टू 1/k करिकी सही पॉइंट 0 dB एक्सिस मार्क करिकी +20 dB ड्रॉ करियार अछि हला। तो एटा हम देखि परिबा एटा +20 dB के माइनस रु जाई की 0 हेछि सो इट इज ए +20 dB पर डेकेड स्लोप। तो 0 dB रे वी हैव टू टेक दिस 1/k फ्रीक्वेंसी। तो सही फ्रीक्वेंसी रे हमरो इंटरसेक्ट करिवो 0 dB एक्सिस को हला। तो तमे ड्रॉ भी करि परिबो हाथ रे चेक करि परिबो और जहार मेटलेव अछि देखि परिबो। तो समस्त प्रिपेयर थी नेक्स्ट क्लास में पढ़ी के पूरे प्लॉटटा पचारे केतरा क्वेश्चन तमाने कि डाउट पचारनो मोर डाउट अछि तमानको परे